Hi, Sterling Allan here, PESN. We are at my dad's house today, David Allan. He's going to tell us about the Allan variance that he came up with as his master thesis and some subsequent equations that are used in international timekeeping, as well as telling us about a book that he just finished this last week. I went to a book fair to introduce it. It's called It's About Time. And I should mention, you see that on the piano there is a globe. That's an award he won at Edinburgh, Scotland, 2012, called the Time Lord Award, where he was recognized as the world's premier time keeper or time connoisseur. And so he's going to tell us about these equations and about his book.
Every clock is imperfect. There is no perfect clock anywhere. And so man, as he generates time, uses pendulum-like devices. Atomic clocks differ from a pendulum in that you have an electromagnetic photon vibration associated with a quantum transition in an atom. Currently the definition is based on cesium. And just for fun, the definition of the second today is 9192631770 cycles per second, which is called a hertz. And so when that many cycles of a quantum transition and the cesium-133 atom occur, you have 1 second. As I look back at that, the thesis that I was working on was extremely challenging, and it was basically saying to the statistical community that you don't have an answer for us, that what you're doing does not work, and therefore we need a new solution. And I feel that along with the help from my colleagues, the inspiration that I got from the heavens helped us bring about this new approach to how one can characterize clocks in a very broad spectrum way and get the answers that we needed. At the time when this was developed, no one had a clue of how far it would go, but the Lord knew, and I believe because I did things His way rather than my way, that made a huge difference, and that He gave me the inspiration and help that I needed to solve the problems associated with this new technique. Welcome to our home. This book, It's About Time, could also be called Standing on the Shoulders of Giants. It's been my privilege over my 54 years in the timekeeping business to be associated with some of the most remarkable people on the planet who have been the developers of the atomic clock system throughout the world. And I've been privileged to know several of them and be associated with them in this work. So I'm very grateful to be able to share some perspectives about the history of timekeeping and kind of why we are where we are and where we are in time. This astrolabe type of sundial is used in observatories to determine the position of the sun with respect to the spinning Earth. And if you use that as a timekeeper, you'll see time fluctuate over the course of a year, plus or minus as much as 15 minutes. And variations in astronomical data were shown by the atomic clock metrologists back in the 40s and 50s to be inferior to what we could do with atomic clocks. In fact, if you go from here to where we are today, we're about 1 billion times better in timekeeping ability, which is astounding, and that's been my privilege to see my colleagues develop these kinds of technologies over these several decades that I've been involved. As we think about timekeeping, one can first of all know that every clock is imperfect. There is no perfect clock, and you can't extract time from the universe. And so what you do is take a pendulum-like swinging device that has a periodic motion, add up those periods to make a clock. Atomic clocks are basically no different than a physical clock, like a pendulum, in that they use a frequency vibration of a photon, the electromagnetic signal coming from a quantum transition, but you can think of it the same way. It's an oscillator, something moving back and forth that you count. And since every clock is imperfect, measuring those imperfections is a very important part of the business. I have here a simple equation, y equals nu of t minus nu zero over nu zero. We can think of nu zero as being the ideal frequency of a clock. This is the actual frequency, which is always different than the ideal, divided by this ideal. So if this number is zero, if y is zero, you have a perfect clock, which you never have. And so measuring what happens with y tells you everything about the performance of a clock. And the y value for the Earth is like to 9 significant digits, 10 to the minus 9, whereas atomic clocks today, this value will be 10 to the minus 18. In other words, timekeeping ability has improved by a factor of 1 billion since I've been involved with this community, which has been spectacular to watch and to be part of. So when I was working on my master's thesis in 1965, measuring these deviations was a very important question. Classically, it was shown that the variations were not well behaved in a statistical sense. In mathematics, we call it non-stationarity. In layman's terms, you end up with deviations that continue to walk off and you don't have well-behaved values. These processes are called often flicker noise-like, and they don't converge in classical statistics. And so a new way of looking at these variations in clocks was needed, and that was the problem that I was attacking with the help of Dr. Barnes and several other colleagues over the years. We developed what the world now knows as the Allan variance, which is measuring the variations in this clock rate. This equation is really very simple when you analyze it carefully. All you're doing with this delta is measuring the difference of the change in y from one moment when averaging time tau to the next. You square it, you average it over some data set, divide by 2 to make it equal to the classical variance if you have classical noise, which you typically don't in atomic clock variations. So this allows us to characterize both the level and kind of noise very quickly in an atomic clock. And it has been adopted because of its utility as a international standard for clock characterization. This was published in 1966 in a special issue of the IEEE called Frequency Stability in February of that year, along with several other papers. Then, because of one slight ambiguity problem with this equation, in 1981 we developed what's called the modified Allan variance, and here we have it in terms of x. If you'll notice this little equation, the frequency variations are the time derivative of the time deviations, dx dt. So we can think of x as the time variations and y as the frequency variations. And so in this case, we're taking what's called the second difference of these average time variations, squared, averaged over some data set, and divided by the integration time, the averaging time, to get this variance. And this is used to characterize time and frequency distribution systems. So you have a atomic clock in the laboratory, you want to send that out and share it with the world so they have a calibration standard, and this is used to characterize those time and frequency distribution systems.
When was that adopted?
In 1981 it was developed, and in 1988 it was made an international standard for comparing clocks, for comparing distribution systems. In the late 1980s, the telecom community came to us and said, "You've done this for atomic clocks, can you do something for us in characterizing telecom networks?" And we asked them to give us some data. They did, and we analyzed the data and looked at variations in network synchronization problems, and ended up with what's called a time variance. And it's a function of this modified Allan variance, and the 3 normalizes it to be equal to the classical variance if you have classical noise, which you typically don't. This also is convergent and well-behaved in all kinds of noise network configurations. So it now has been adopted by the international telecom community to characterize network stability.
In each one of these equations, you have said something that's puzzling me. You say that in relation to the classical, and then you say something like, which it isn't, but then you're saying that the equation is used as if it is. Maybe you could explain for us.
The classical variance does not converge and is not well behaved for the kinds of noise we observe in nature. You have what's called flicker noise, which is mathematically non-convergent, and the classical variance mathematically blows up. So that was the big challenge of the thesis that I wrote back in '65, was to, thanks to Dr. Barnes' work and others, we were able to solve that problem and come up with a variance that was well behaved, that did show how the variations worked, and would tell you whether it was flicker or white or random walk or whatever kind of noise. And there are several different kinds of noise processes in clocks. And this allows you to characterize all of them very well for the kinds of variations we see in natural phenomena. It occurs pretty much everywhere in nature. Everything changes. And so you see these changes varying with time. You want to know the level as well as the kind of noise properties. That's very important. For example, GPS, time prediction is essential. And so this was used to characterize the clocks for GPS. Then you could come up with equations to know how well you could predict time from one upload for the satellite to the next, to know if you could keep time to a billionth of a second, which is what GPS wants to do to give you the navigation accuracy that you get today. Does that answer?
Yeah. Also, you have that frequency of the cesium on the top. Do you want to mention that?
Yes. The definition of the second went from Earth time to the orbit of the Earth around the Sun in 1956, and then they realized that was too difficult to measure, and so as atomic clocks became available in 1967, cesium had been shown to be much, much more stable. This value of Y was much smaller for cesium than it was for any astronomical measurement, and so the definition of the second was based on a quantum transition in cesium-133. It's a nuclear magnetic resonance. It's the interaction between the valence electron and the magnetic moment of the nucleus. When the spin of the electron flips from one state to another, it either absorbs or gives off a photon, and that photon's frequency is 9192.631.770 cycles per second, or hertz in terms of physics language. And so when that many cycles transpire in this photon, you have one atomic second. And that is the definition of the second for the world to this day.
You mentioned the IEEE publication of the Allan variance. We're coming up on 50 years, and I understand they're going to be doing a special issue just about the 50th anniversary of the Allan variance in 2016?
Yes, I just learned about that a couple of weeks ago. A colleague from Italy sent me an email, and a colleague from Boulder, that they're going to do this special issue of the IEEE ultrasonics, ferroelectrics, and so forth. It's a subset of the special of the proceedings. And the whole issue will be devoted, and they're soliciting papers from all over the world for people to talk about how this has helped, upgrades that have improved the concepts here, better ways of estimating it has evolved significantly to the work of several other colleagues. But anyway, it had its launch pad in 1966, and they will celebrate in this special issue. They've asked me to write a couple of papers for it, and that would come out sometime in 2016. So they're soliciting papers now. There's a web link that you can go to that describes what they want.
Let's talk about your book. It's about time.
This is kind of a combination of my science efforts and my religious activities. I've always been interested in truth in a very fundamental sense. How does God's time work? How does man's time work? The comparison of the two. And so this is an effort to describe all of that, man's time, God's time, where we are in time. And it's been an intriguing research project. It represents kind of my lifetime of research and efforts. The beautiful thing about it is that it integrates science and religion, because truth is truth, whether it comes from science, whether it comes from religion. If it's true, then it will harmonize. And I've been able to show that in this book, that we have indeed a beautiful harmony. I have several experiments described in the book which basically validate the message of the Bible and of the scriptures that we have in a very fundamental way. To me, it's scientifically non-deniable, but that's for the reader to yet determine. And it just came out just a week ago, so we're excited to share that. It's available at this website. One can acquire the book. There are 25 chapters in the book, in 3 sections. The first section enlarges the scientific method in a very fundamental way. One needs to realize that there is a postulate that's pervasive in history, in recent histories that have been written, and recent science that excludes God. And that postulate has a very fundamental impact on what we have in our histories and in science. Many scientists say you can't do good science if you are religious, and vice versa. And I have basically proven that that postulate is false. And I've tried as much as possible to use reliable data to show this marriage of science and religion. So the first part enlarges the scientific method to do that, and then I launch into using that to ask fundamental questions about life, why we're here, where we came from, where we're going. And in that enlarged context, we answer several of those questions in a very profound way. Then the next section, I basically take the foundation developed in section 1 and say, okay, let's analyze the traditions of men that have crept into our society that are harmful. And you find several false traditions that have had a serious impact on body, mind, and health issues, to cause disease, to cause the problems we have.
You mean body, mind, and spirit?
Body, mind, and spirit. And as a result, I give both the causes and the solutions to how we can have better health to our body, to our minds, and to our spirits, to bring a oneness in with each other and with our Maker. The last section goes into how GPS works, how man's time is generated, God's time. It also launches into the unified field theory work that we did over a decade ago, which is very exciting and ties into Sterning's work in a very fundamental way, because it implies that there is a field external to what we see here throughout the universe that one can tap from and obtain alternative energy sources. And we've done 7 experiments to date. Those are described in chapter 21 of this book, validating this new unified field theory. We feel like we're just on the baby step brink of understanding, if you will, God's physics, about how He has structured the universe. But it's very, very exciting. And with these experiments have been, as I say, validated the basic theory. So we have the theory and experiments to go along with it. We've observed quantum transitions in these, what we call diagonal field line structures that permeate the universe. And so we're just in the beginnings of seeing lots of new things that I think will come out of it, alternative energy sources that I believe, will come forth when we're ready for them. We're so fossil fuel based now that it creates very serious problems. And I think we can move away from that as we understand the ways that God has of doing His work, and we tap into that through our worthiness, if you will, to get away from the tyranny that we're now under and the control that exists in our society. The book concludes with a summary of how, when we understand these principles, that we can have a much better world. We live in the most exciting time in the history of the planet, and it gives great hope and purpose for who we are, where we are, and what we can do to make the world a better place.
You talk quite a bit about health in there.
Indeed. I'm 77 years young. I still am an avid mountain biker, and the principles of health that we have studied have helped both my wife and I overcome several of the American modern diseases that tend to cause serious problems in many people's lives. And we've been able to see reversals of those. I used to wear glasses. I don't wear glasses anymore. So understanding why these health issues are serious in our society and how we can correct for them is a very important part of the book. And we address those problems and solutions in the book as well.
Do you want to talk briefly from a spiritual vantage point about how the Allan Variance came about?
Yes. I graduated from Brigham Young University in 1960 with a degree in physics, and went to Boulder, Colorado with the intent to go to the University of Colorado to get a doctorate so that I could come back to BYU and teach and do research. I love to teach, and I thought this would be a fine direction to go. My wife and I both felt good about it, and so we moved our little daughter, who was a half-year-old, Shelley, our firstborn, to Boulder, Colorado in the summer of 1960 with that intent. I was in no hurry to get a degree, advanced degrees, because I had to work full-time for the Bureau to pay for my schoolwork, classes that I was taking at the University of Colorado. And I was active in the church, doing things there, and working in the community, and so I was involved pretty heavily, and so I only took 1 or 2 classes a semester. In 1965, when I was working on my master's thesis, I received a call to serve in a major leadership position in our church, and this was not according to my plan. It seemed cross-grained to where I was headed, and so I asked for time to think about that and pray about it, and I went into an intensive fast. Into the 4th day, the Lord gave me an answer, that this was His call, and so I accepted it, and was told at the time also that this was preparatory for me to serve as a bishop in our church, which was a total surprise to me. I told no one about that except my wife, and a year later they reorganized the church in Boulder, and I was made bishop of the new ward organizational congregation in that area, in fulfillment of what the Lord had whispered. And as I look back at that, the thesis that I was working on was extremely challenging, and it was basically saying to the statistical community that you don't have an answer for us, that what you're doing does not work, and therefore we need a new solution. And I feel that, along with the help from my colleagues, the inspiration that I got from the heavens helped us bring about this new approach to how one can characterize clocks in a very broad spectrum way and get the answers that we needed. At the time when this was developed, no one had a clue of how far it would go, but the Lord knew, and I believe because I did things His way rather than my way, that made a huge difference, and that He gave me the inspiration and help that I needed to solve the problems associated with this new technique.
I want to just mention in this context that because of accepting this call and the conflict between work and trying to raise a family, you ended up not getting a doctorate. This was your master's thesis. which has become the foundation of international timekeeping and also telecom, which is very significant. And you've traveled around the world and have lectured with rooms full of PhDs, and you don't have one, and yet you're known as the praying physicist.
Yes. So I give the credit where it's due. And I'm grateful to be a servant of God in that regard to help, because it brings about a clarification, a unification that otherwise could not or would not have been there. So I am extremely grateful for both colleagues and for the guidance from heaven. I believe that this did come as a result of my willingness to try. And the interesting thing happened, once I learned that lesson, I applied it again and again. And there are several other inventions that are attributed to me, which I know came from above, because I was willing to ask the Lord, how do you solve this problem? GPS Common View was a direct answer to prayer. We needed a way to communicate time around the globe, and that came in mode of prayer. I remember it very well. I was asking, how can we solve this problem? And the Lord gave me an answer. And it's now used for international timekeeping, for generating time for the globe, to move clock time from Boulder to Paris and from other places around the world, so that time can be kept as well as it is.
How integral is that to GPS and our devices that we use today?
GPS Common View came as a result of GPS being up there. I was asked in the beginnings to help with the GPS program and characterizing the clocks, and that's a separate issue, but GPS Common View is used in international timing, but the characterization of clocks using variances like this are essential to it today. It would not work well if you didn't know the performance of each clock, how well it works, how well you can predict time. So these are methods of parameterization so that you can optimize your GPS system. One fun thing in the book is that I have another idea, which I believe came from above, which can show you how to improve GPS by as much as a factor of 100. So it could be, we can determine the position of the satellites to perhaps sub-centimeter in some future years if this is employed. Lots of problems to be solved in that process, but the theory seems to be there, and we're anxious to share this with colleagues and see where it goes.
You also, in addition to publishing your new unified field theory in chapter 21, you talk about a discovery you made in the scriptures about the phrase, and it came to pass.
Yes. Dr. Felix Meinhardt, professor of Meinhardt, Pretoria University, was asked to translate the Book of Mormon into Afrikaans. And in that process, he saw these phrases jump out at him which were not English. And it came to pass was one of those phrases. And once I learned that from him, I felt to study that phrase. And lo and behold, as you go through the Bible, the Book of Mormon, and modern scriptures, you find that it was used anciently and it diminished in its usage over time. For example, in the book of Genesis, 61% of the chapters use the phrase. In the Book of Mormon, 63%, so it's about the same. If you go into the New Testament, it's much diminished, and only Matthew, Mark, and Luke use it. For example, Luke 2, and it came to pass, the decree went forth from Caesar Augustus, all the world should be taxed. Everybody knows Luke 2 and the birth of our Savior. But Peter, James, John, Paul, and Jude use it 0. And interesting, Joseph Smith in the revelations that he received uses it 0. But yet in the Book of Mormon, it's replete. And I thought, this is an interesting occurrence, because if you look at when it occurs, you find that it has historic significance. It always is associated with, like the Lord is saying, this is an important event, pay attention. And so my thought was, as I look at the data, it looks like it actually goes all the way back to Adam and is a phrase associated with the Adamic language diminishing with use over time. So I asked the question, how can I test that hypothesis? And so I thought, we have a record of the Jaredites, which goes back 4,000 years, and it's the only record we have of a people whose language was not confounded at the Tower of Babel. And so I thought, let me look at that set of scriptures and see the probability. Turns out that 100% of those chapters use that phrase. That was translated by the prophet Moroni, and he uses it himself, 0, but in the context of the translation, 100%. So it gave a perfect validation of the hypothesis that this was a marker, if you will, in the ancient Adamic. More recently, I learned of a work of Professor Leonora Leet, who teaches at the University of New York. She's written a book on the Kabbalah, and she has, in her book, tells about that phrase, and it came to pass that it numerically is equivalent to the word El, which is God. In other words, when you see that phrase, you see that this is God saying to you, this is important. And she also says that these are events of the past. And I found that very fascinating. Then she goes the next step to the phrase, and it shall come to pass, and she ties it numerically to Jehovah, which is the most sacred name of God, and events of the future. So once I learned from her that model and theory, I thought, let me look at the data. So I extracted some 200 occurrences of that phrase from all of the scriptures, Bible, modern scriptures, Book of Mormon, and I found that indeed her hypothesis, or her statement, theory if you will, is exactly on target with the scriptures as we have them, that it all ties to our day and to the second coming of the Lord. So the model seems to fit perfectly, and this is all written up in the book, describing this series of events that give you data to solidly tie together all of our scriptures in a harmonious way and lead us back to Adam having the most pure language and this wonderful marker that ties us to his language and to him and the beginning of the human family.
Thought of a question I'd like to ask. You talked about freedom and threats to freedom quite a bit in the book. Do you want to address that just for a minute?
Yes. One of the other reasons why I felt impressed to write the book was because of the attacks on freedom, the taking away of our Constitution, principles. We see a great deterioration moving away from what we had given us by our founding fathers and mothers. And so I address those questions and issues in the book significantly. And Tim Ballard has written some great books called The American Covenant, and I based some of my work triggered off of his. He was featured on Glenn Beck. His book went to number 3 on Amazon because of its significance in understanding who we are in this, if you will, land of promise, which was to be the land where truth could go forth and in the principles of freedom. And this is very important to me, and it's a very important part of the book. I think freedom of religion, freedom of life, free energy all tied together in a very fundamental way. And so I'm very happy with the work that Sterling's doing to help promulgate that which could give us next generation freedom from our bondage to fossil fuels, for example. And it all ties together in a very fundamental way. So there are significant portions of the book that address those issues about our constitutional principles. I asked the very serious question, is our defense our defense? This is all one section of the book, and you'll find some very interesting data, if you will, around that, showing that we are in a serious state of affairs in terms of loss of freedom, and that there are solutions that we can come up with to move away and out of the bondage and the tyranny that many of us feel.
Also in the book, you talk about as a data set the books that have been written about near-death experiences, and you came up with a number I was totally unfamiliar with, the number of books or the number of experiences is like 3 to 5 million worldwide?
Yeah, in fact, chapter 2 takes the enlarged scientific method that I have developed, which is very fundamental, and it goes to a data set of life before life experiences that people have had, and near-death experiences, people going across the veil and coming back. There are 13 million documented near-death experiences. And Sarah Hines, who is a good friend in Mesa, Arizona, has written several books on life before life. And so taking these as data, and they are data because as you look at the stories they share, they're irrefutable. In other words, they could not have known what was happening had they not been on the other side and free from their body at that point. So you have documented data both for life before life and life after life experiences that I've been able to document is in chapter 2, which is a very foundation of kind of why we're here, who we are, and where we came from. So it's very important data for me.
You worked for NBS, National Bureau of Standards, NIST, changed the name to later, for many years. 35, you said?
32.
32. Retired in 92. And then September 11th happened, and NIST ended up, in my opinion, covering up for what happened as what I see as an inside job on September 11th, bringing down those towers at free fall speed. That's not something that could be done without help. You are from NIST, and your colleagues were involved in this cover-up. How do you feel about that?
I don't think my colleagues were. The folks that I work with in Time and Frequency Division are some of the finest folks on the planet, and I think that this was external to anything in Boulder. I think it had to do with the political leverages back in Washington. I think integrity is so important in all that we do, and that's a fundamental premise that I've tried to follow in the book. And I'd like to share a little story about integrity and a person that was associated with helping me bring the book forth. I had a class at BYU in the 50s from Chauncey Riddle. Professor Riddle is a philosophy of religion expert, taught there for 40 years. He, if you go to his website, which his students have put up, Chauncey C. Riddle, they claim, and I believe they're right, that he, along with two other notables, are the best professors BYU has had in our generation. And I happened to meet Professor Riddle going to the temple one day and up in Provo, Utah.
About a month ago?
Yes, about a month ago. And I told him, June 27th, in fact, that what I had learned from him in that philosophy of religion class was a major part of the book that I had written. So he asked me, what's the book about? When I told him, he says, I'd like to read it. And I says, well, we're in the editing phase. Would you care to help us give me some feedback? And he says, I'd love to. I said, do you have time? He says, I'll make time. And so I gave him my best effort on the following Saturday morning, and the next Tuesday he had finished. This is a 400-page book, and I was aghast. And he said, I'd like to visit, got some questions and comments. We spent the most productive Tuesday evening together. He came down, my wife fixed a wonderful meal, and we had just an incredibly productive evening. It ended up causing me to write chapter 25 and making some other changes in the book per the information that and feedback that I got from him. His book, Think Independently, which is not readily available, is a marvelous book that he gave me, and I've given him a copy of this one. But I feel that that whole process of meeting him, having him involved, was providential. I saw the hand of God in helping him be a part of it, and we become very good friends. Now, some 50 years later, after having taken his class back in the 50s, when I was doing my undergraduate work.
just from a timing point of view, I remember you left that morning to go up and you're going to go to the temple, and he happened to be the officiator, and you ended up talking later, and so that seemed like a really, the timing of when he showed up and ended up writing the foreword for the book with his credentials, it seemed very providential. I wanted to mention something too, just, in your equation, you've got these deltas change in, and I wanted to note that this is an older picture of NBS. NBS is right here, and its sense is built out over here. But notice that the streets create a delta shape, which is kind of curious.
Yes. Worked there for 32 years.
Yeah.
Yeah, but I fully agree with Sterling. I felt the hand of Providence in bringing Professor Riddle in to help us write the foreword and to critique the book and to give us additional insights and information. And if you can get hold of his book, Think Independently, I highly recommend it. It will help. It's a life-changing book. It allows you to see and think clearly about who we are, where we are, and what's going on in terms of these false paradigms that have crept into our society and how we can circumvent and overcome the effects of them. So I'm extremely grateful for his friendship and contribution.
The principles of that book are very similar to the ones that are inside of your book.
In fact, as I read his book, which I did after he gave me a copy, I can see why he was extremely interested in this book, because they overlap so significantly.
And your book is available at Amazon.com as well?
It's available, it's published by Liberty Library Publishing. If you go to this website, you'll find two links, one for Amazon and one for the publisher. It costs you 50 cents more to go to the publisher. I would recommend you do it there. Just because I think our publisher's done us a great job, and it would put another nickel in his pocket.
All right. Thank you.
Of the sun with respect to the spinning earth, and if you use that as a timekeeper, you'll see time fluctuate over the course of a year, plus or minus as much as 15 minutes. And variations in astronomical data were shown by the atomic clock metrologists back in the 40s and 50s to be inferior to what we could do with atomic clocks. In fact, if you go from here to where we are today, we're about 1 billion times better in timekeeping ability, which is astounding, and that's been my privilege to see my colleagues develop these kinds of technologies over these several decades that I've been involved. As we think about timekeeping, one can, first of all, know that every clock is imperfect. There is no perfect clock, and you can't extract time from the universe, and so what you do is take a pendulum-like swinging device that has the thesis that I was working on was extremely challenging, and it was basically saying to the statistical community that you don't have an answer for us, that what you're doing does not work, and therefore we need a new solution. And I feel that, along with the help from my colleagues, the inspiration that I got from the heavens helped us bring about this new approach to how one can characterize clocks in a very broad spectrum way and get the answers that we needed. At the time when this was developed, no one had a clue of how far it would go, but the Lord knew, and I believe because I did things His way rather than my way, that made a huge difference, and that He gave me the inspiration and help that I needed to solve the problems associated with this new technique. Welcome to our home. This book, It's About Time, could also be called Standing on the Shoulders of Giants. It's been my privilege over my 54 years in the timekeeping business to be associated with some of the most remarkable people on the planet who have been the developers of the atomic clock system throughout the world. And I've been privileged to know several of them and be associated with them in this work. So I'm very grateful to be able to share some perspectives about the history of timekeeping and kind of why we are where we are and where we are in time. This astrolabe type sundial is used in observatories to determine the position.
And about his book.
Every clock is imperfect. There is no perfect clock anywhere. And so man, as he generates time, uses pendulum-like devices. Atomic clocks differ from a pendulum in that you have an electromagnetic photon vibration associated with a quantum transition in an atom. Currently the definition is based on cesium. And just for fun, the definition of the second today is 919263177770 cycles per second, which is called a hertz. And so when that many cycles of a quantum transition and the cesium-133 atom occur, you have 1 second. As I look back at that,
Hi, Sterling Allan here, PESN. We are at my dad's house today, David Allan. He's going to tell us about the Allan variance that he came up with as his master thesis and some subsequent equations that are used in international timekeeping, as well as telling us about a book that he just finished this last week. I went to a book fair to introduce it. It's called It's About Time. And I should mention, you see that on the piano there is a globe. That's an award he won at Edinburgh, Scotland, 2012, called the Time Lord Award, where he was recognized as the world's premier time keeper or time connoisseur. And so he's going to tell us about these equations